Welcome to Gopher Security. Today I'm going to walk you through our MCP gateway using real-world enterprise security use cases, using Microsoft Sentinel for security operations while running inside of Microsoft Purview governed environments. So we're going to start here in our Gopher dashboard and spin up an MCP server live and walk you through the security controls, then move over to Claude and show you what happens when a security analyst can operate their SIEM through a natural language with full governance at every step. So here I'm creating an MCP server. And I'm selecting our pre-configured toolkits. And we'll go ahead and name our server Sentinel MCP server v2, as well as giving it a good description, which helps your team manage multiple servers across your organization. We'll select from our certified toolkit library where we have pre-built toolkits ready to deploy. The Sentinel toolkit has 48 tools. So we'll select this one and configure it through our configuration menu. For this example, we'll provide all of the tools that the Sentinel toolkit comes with, covering their full API scope. And we'll do the heavy lifting for you so you can integrate it into your system and you focus on your AI workflows. For the authorization step, we'll create a new authorization, which will be Sentinel auth server. And we'll select the tool scope, which is the default tool scope with offline access. We'll select this. And we'll create the authorization. Once the setup is done, the flows across all of your toolkits under this server. So when I connect it to Claude in just a few minutes, no additional credentials are needed. So here I'm authorizing against our Azure environment. This connects to our workspaces, Gopher, Sentinel overview, and resources groups together. And once it's done, every tool call from any connected AI client goes through this authorization. Now that I verified the MFA, our authorization is connected, so we can deploy this server. So now we see that the server is fully created, MCP server, connected to our Sentinel toolkits. So here we have the streamable endpoint URL that we can connect to our AI client. Before we move on to that step, authorization is not the only critical part for your security because it still leaves your API wide open. If someone's credentials are compromised, they get access to everything. And that's not acceptable for enterprise security operations. This is why we can control the policy framework through the Gopher policy dashboard here. As you can see, this enforces least privilege access on every tool call, and policies attach to tools and identities, making every call identity aware and context aware. A junior analyst gets read-only access to incidents, lists, and view-only. A senior engineer gets full CRUD. A SOC lead gets automation, rule creation, and playbook execution. Off-hours access can be restricted completely. And this isn't just with Sentinel. Through the gateway, you're governed access across all the connected systems: Sentinel, Purview, Gmail, Salesforce, whatever toolkits you've deployed. And you're segregating who could use what tools across your entire stack. So now that our server is created, policies are all set, let's go ahead and spin it up. We'll go ahead back into the newly created server. We'll select the endpoint URL here and navigate over to Claude and connect the new MCP server in the settings menu, custom connectors, add a custom connector, use the endpoint URL, name this Sentinel MCP, add this to Claude. The new Sentinel MCP has been connected. Our workspace has active indicators from a coordinated phishing and data exfiltration attack that hit our finance team. Let's pull up what we have. Let's list our threat intelligence indicators. Show me the highest confidence ones first. So now we get back 8 active indicators, all sourced from the Gopher Security SOC. Here's the workspace contains. So attacker with this IP address. We also see ransomware C2 server. We see spoofed phishing domains, gopher-security.com. We see phishing domains, filtration endpoints, plus a Trojan binary hash, a brute force IP, and a port scanner, all tagged with MITRE kill chain phrases. From reconnaissance through action on objectives, this level of structured threat intel is what powers automated detection downstream. So now moving on, show me all the watch lists in this workspace. And the agent pulls back 4 active watch lists, blocked IP addresses, known malicious IP to monitor, VIP users, so enhanced monitoring, high value employees with tier 1 monitoring, including our CEO, CFO, and CTO, and head of security, James. Blocked domains for malicious infrastructure, and compromised accounts for coordinated attacks. So now we'll ask it to show me the items in the compromised account watch list. Here we see the 3 accounts that were compromised during the attack: the CFO, the finance department. Notice the details here in each entry include the compromised type, remediation actions taken, and link to the incidents, references, and dates. Now we can move over to attack chain forensics. One of the greatest parts of the demo, where with one prompt, the agent calls for multiple Sentinel tools, incident alerts, entities, threat intelligence watch lists, and pieces together the complete attack narrative. So let's go ahead and ask Claude, explain how this phishing attack happened. Give me the full forensics, attack chain, and timeline using the incident data, threat intelligence, and compromised accounts. Phase 1, where the attacker registered gophersecurity.com, a typo squad of our real domain, 48 hours before the attack. Privacy protected Whois via Namecheap. They set up a fake Microsoft OneDrive login page on this infrastructure and configured the credentials. In phase 2, the phishing email sent to 12 finance department users. The spoof domain failed SPF, DKIM, and DMARC checks, and the email gateway intercepted 9 out of 12, but 3 of them got through. And we see the users that received the email, which were Rachel Kim, David Okoff, and Michael Torres. In phase 3, all 3 clicked the malicious OneDrive link and submitted the credentials. The attacker prioritized Michael Torres, the CFO. They harvested his session tokens to bypass MFA and created an inbox forwarding rules to intercept communication and began automated data exfiltration using Python requests tooling. The timeline shows 25 minutes from first click. The attacker logged in 18 minutes to exfiltration, 60 minutes to active exfiltration, and 83 minutes total from first email to full containment. A security analyst would spend weeks piecing this together from across Sentinel UI, incident badges, alert timelines, entity views, threat intelligence, one prompt through Gopher's gateway, and you have the complete forensic picture all in one go. So now for remediation. The agent cross-references compromised account watch lists with threat indicators and incident data to generate remediation status. So let's go ahead and ask, how do we remediate this attack? Show me what has been done and what's still needed. So now the workspace shows remediation is already tracked for Michael Torres account, disabled, all sessions revoked, malicious inbox rules deleted. We have blocked email gateways. We have policies blacked for exfiltration, spoof domain reported to Namecheap. We also see the account remediations, task force reset, MFA re-enrolled. We have David's MFA re-enrolled. Phase 2 hardening identity and access, conditional access impossible, a travel rule detection for all users, hardening, phase 4 of data protection, awareness and training, Sentinel detection for infrastructure. And so we can see that's an actionable cross-reference remediation status generated for you live in the workspace and not a generic AI playbook. Now let's go back to the Gopher dashboard and look at what was captured. So we'll go ahead and navigate over to the metrics section, and we can see full cross audit trails, every tool call from Claude to Sentinel, MCP server, what was requested, what parameters were sent, what was returned, and how long it took. When we query those threat indicators, when we pull the compromised account watch list, when the forensics analysis ran, it's all here. Logs give you a time series detailed on individual events, exact timestamps of every tool call, and metrics give you event-driven analysis, why tool calls were called, performance latency, usage patterns, and when secure leadership asks, what are AI agents doing inside of the SIM? This is the answer. Everything we just did operates under the Microsoft Purview data governance and compliance controls at Azure layer. Data classification, sensitivity labels, DLP policies, insider risk management. So dual governance model, which has Gopher MCP level zero trust policies controlling which tool calls each identity can access, and layered on top of Purview's data level protection. For enterprises running the Microsoft security stack, this is the architecture that makes agentic security operations viable without sacrificing compliance. So let's recap what Gopher delivers in this demo. On-demand MCP server creation, certified toolkit library, unified authorization, zero trust policy framework, and privileged access tool call, identity-aware, context-aware across your entire stack, full observability, tracing, logs, metrics, complete audit trail of every agent action, dual governance with Gopher MCP, policies layered with Purview data level compliance. And the results speak for themselves. We pulled 8 threat intelligence indicators with kill chain mapping. We identified 3 compromised accounts with remediation statuses. We reconstructed a full multi-phase attack chain from domain registration through credential harvesting through data exfiltration, and generated cross-reference remediation plan, the kind of analysis that takes a security team weeks, if not months. 3 words: connectivity, security, visibility. Thanks for watching, and reach out to us if you have any questions. We'd love to see how this works in your environment.